So what we'll be starting with principle of superposition now. So what we had done in the previous class was you had this member. Let us say this is a member which was joined in series, and it was subjected to a certain load. Let us say. So here what happens? Let us say this is 1, this is 2, this is 3. Then the total change in length or is given by delta L of change in length of 1 plus delta L of 2 plus delta L of 3. So the load applicable in all the three cases were same. So this was actually PL1 by A1 E1. Why E1? Because it can be made up of different materials also. So this is PL2 by A2 E2. And similarly for this you have PL3 divided by A3 E3. If you look at this equation, you can say that it carries the same load for all sections. That means the load applicable is same for all the sections. All the sections are subjected to the equal amount of load. Now let us take a real life example. Let us take a chassis of a vehicle. A vehicle. So vehicle means let us say a car. So what do you mean by a chassis is something of this type. This is the shape of a chassis. Now here what happens? These are 4 bolts. These are 4 bolts placed on the chassis. Chassis in a car means this is a structure on which the engine is supported. On which the engine is supported. So when the engine is supported here, the load taken by different parts. So if you have opened the bonnet of your car, you must have seen that where the battery is placed, you have a small gap. See? And the density of material, or you can say the weight which is distributed, is not equally distributed on these 4 bolts. This portion, it carries the maximum load. This carries the maximum load, and these two are end supports. So what happens is, in real life situations, you come across a composite. This is a section in series. You, in real life applications, you come across a section where it is subjected to different loads at different points. So you have different loads acting. So let us say that you have a composite section like this. This is a very typical problem. This is beyond your capability of solving it right now. Now this type, the purpose of telling you this was made to understand that you can have a system which is arranged in series, but it carries different loads at different points. So let us say that this is some load 20 here, this is some load 60 here, this is some load 30 here, and this is some load 50 Newton. All, let us say everything is. So you can have a composite section like this, which is made up of 3 sections which are joined together, and they carry different loads at different points. So one small complicated example is a chassis of a vehicle where each joint, or each joint means each joint is subjected to different loads at the same time. So these types, now here what you can see that it is having the same P, you have used this. Here if I use, if here also delta L is equal to delta L of 1 plus delta L of 2 plus delta L of 3. Now if you take this as section 1, this is section 2, and this is section 3. If you take section 1, it is 20 on one side, 60 on the other side. So for P, what will be the value of P that you will be using, whether it will be 20 or 60 or mean, mode, median of what. So you need to decide upon that. So to decide upon that, we use principle of superposition. So principle of superposition is used to solve problems where bars have been joined in series and each joint or each node is being subjected to a different load. It is not subjected to the same load throughout. So when you have bars joined in series subjected to different load at joints, they are solved by principle of superposition. Now, with the help of a small example, I'll take up a small example and try to make you understand what is principle of superposition. So let us take a member. Let us take this member. And let us say this is uh, 20, this is 60, this is 30, and this is P, some value P. So let us name them. This is A, this is B, this is C, and this is D. Everything, all loads are in a Newton. So according to principle of superposition, according to principle of superposition, it says that sum of load acting on in one direction of a body is equal to sum of forces in another. So it says that sum of forces acting in one direction of the body will be equal to sum of forces in another. So in this problem, you can say that 20 plus 60 will be equal to 30 plus P. Now the direction of P will either be predefined in the problem or you have to select and effectively apply it. So if you solve this, therefore P is equal to 50 Newton. So it says that P comes out to be 50 Newton. Now this is a single equation, so you can solve to the maximum any one variable. So out of all these data, only one can be solved out. So P has been finally arrived at 50 Newton. Now your job is to balance it. Now the job is to balance this entire system, because for if you want to find out the total delta L, the total delta L will be given by delta L of AB plus delta L of BC plus delta L of CD. Now the problem is, what is the delta L applicable? What is the value of P that is applicable for AB? So for AB, you have two different loads acting in two different directions. Like in BC, you have some load acting in this direction, some load acting in this direction. So direction as well as magnitude, both are a factor here for AB, BC and CD as well. So you first need to find an equivalent amount of load which is applicable for AB. So this problem can be solved by moving in either of the two directions. So what you can say that either you can move in this direction or you can move in this direction and solve the problem. So for simplicity, I'll be solving the problem first from left to right, and then I'll solve the same problem right to left and verify the answers. Okay, so Let us solve from right to left. Sorry, left to right. So if you're solving from left to right, what we do is we isolate the first member. So if you isolate the first member, let us bring AB here. This is AB. So what is acting on A? So this is 20, this is 60. So you have to first decide whether you will be solving the problem from left to right. Once it has started from left to right, the entire problem will be solved moving from left to right. You cannot say that sir thoda sa idhar se kar lunga, thoda sa idhar se kar lunga. No. It has to be either left to right or right to left. That is applicable for the entire problem. So we are solving from left to right. So this is your representation of AB. What you need to do is this 20, when you are moving from left to right, the left hand side load will be called as reference and the right hand side load will be called as manipulator. Will be called as manipulator. So what you do is you add 20 here and you subtract 20 here. You add and subtract 20 kilonewton. So if you bring this member back to that original position, again principle of superposition has been applied. दोनों तरफ 20-20 जोड़ गए. ठीक है, तो आप एक्चुअली प्रिंसिपल ऑफ सुपरपोजिशन से कभी भी बाहर नहीं आ रहे हो, लेकिन उस प्रॉब्लम में ही चीजों को इस तरह से मैनेज कर रहे हो ताकि आपके पास एक सोल्यूशन हो. So what we have done is this is your reference. In the manipulator end, you have added the reference value and subtracted it. So the net principle of superposition is also applicable everywhere and you are not deviating from the problem. Now the physical representation of the problem is this and this should have been represented. Then it would have been correct. So if this and this is represented, this would have been correct. So represent this like this. So your final AB is something like this. This is 20 and this is 20. What are you left with? Come to BC. Now this is BC. Now this 20 has been consumed here. So you are left with 20 in this direction and 60 in this direction. So this adds up to 80 in this direction.
Excuse me, sir.
Huh.
Sir, can you please tell again about the green figure you make?
So this is 80 left here. And what is acting at C? It is 30. So again, so this is 30 here. So what you are doing is add 30. Again, this is your reference. Now this is your reference and this is your manipulator. So what you do is add 30. Sorry, not 30, 80.
80.
You add 80 and subtract 80. Okay.
So 15.
So what will happen now?
So 50.
Why 50? It is one and the same. BC. So what you are doing is this 80 and this 80 have been brought in here. Okay. And they are resolved. What is left? ये 80 और ये 80 आपके बैलेंस करने के बाद बाहर आ गए, छोड़ के क्या आ गए? ये 30 इधर है, ये 80 इधर है. So that means if you draw the third section, CD, it is 30 here, 80 here. That means it is 50 here. And on the other side, you have 50. So the last segment is automatically balanced. If this is not automatically balanced, that means somewhere you have gone wrong. Okay. So this is the entire balance structure following the principle of superposition for this diagram. Now, if you want to find out delta L, total delta L. So for this will be minus 20 L by AE. This will be plus again for BC minus 80 L by AE. And for the third part again plus minus 50 L by AE. So whatever you get, why minus? Because all loads are compressive. So if they are compressive, then what happens? The net effect is reduction in length of the body. So if it is reduction in length of the body, that automatically means that it will be preceded with a negative sign. Okay, so let us take the same case. Now in this problem, what we'll be doing is, we'll be solving the problem from right to left. So for solving the problem right to left, what we need to do is, let us isolate CD. So this is CD. This is 50 here. And this is 30 here. So what we'll be doing is, this, when you are solving the problem from right to left, this is your reference and this is your manipulator. So this remains as usual. We'll be adding 30 and subtracting 30 from this end. Sorry, not 30, 50.
50.
50. We'll be adding 50 and subtracting 50. So this 50 and this 50 form the balance here.
यहाँ कैसे बैठी हो भाई? जाओ ना.
So this 50 and this 50 are actually balancing themselves. What is left is 30 in this direction and 50 in this direction. So
जाओ ना, चाय बनाओ.
please mute yourself. So you are left with 80 in this direction and 60 in this direction. Why 80 is left here? This is 30 in this direction and 50 in this direction. So they both of them add up to make it 80. So this is BC. Okay, again this becomes your reference. This is your manipulator. So you are adding 80 and you are subtracting 80. So this 80 and this 80, they get added up, or they are used to balance the section BC. This is 80 here and this is 80 here. What is left is 60 in this direction and 80 in this direction. Look, 60 in this direction and 80 in this direction means it is actually 20 in this direction. If you see, this is 60 here, 80 here, that means 20 here. If you come to AB, this is 20 here. So finally AB is 20. Now you get the same values, same answer, and the same result loads in, while if you solve the problem from right to left or left to right. So it makes no difference whether you are solving from left to right or right to left. The only thing that you have to keep in mind is half of the problem cannot be solved from left to right and half from right to left. You have to consider the same directions while solving the problem. Okay. So now let us take this very small problem on principle of superposition. मैंने आपको बताया था ना कि चीज़ें उतनी जितनी आसान आपको दिख रही हैं उतनी आसान एक्चुअली होंगी नहीं. So this is a difficult problem that I have taken at the first stage itself. The reason is very simple. I don't need to close the class at 3:30. I can extend it by another 10 minutes. So that makes my work a bit easier. ठीक? And we'll be taking up similar types of problems in the next class also. Okay. So this will make you think a bit. Now, if you look at this problem, this is a bar which has been clamped from both the ends, and you have a 100 kilonewton force being applied here. Okay. Now you need to find out. Let us say this is AB and BC. The problem is find stress in member AB. You need to find out the stress in member AB. Okay. So if you look at this problem, it is clamped from both the ends. Okay. So clamped from both the ends means you arrive at something. So by looking at the problem, you can guarantee one thing, that delta L will be equal to delta L of AB plus delta L of BC, which will be equal to 0. So a net change in length will be 0. एक्चुअली हम इस तरह के स्टेटमेंट नहीं लिखते हैं कि डेल्टा एल ए बी और डेल्टा एल बी सी बराबर होंगे. ठीक है, वो बराबर लिखने का मतलब होता है कि विदाउट सॉल्विंग द प्रॉब्लम यू आर कंक्लूडिंग समथिंग. ठीक है, सो इन इंजीनियरिंग यू हैव टू कीप certain things in mind. So the representation is very important. So the representation says that the total change in length of this bar will be 0. Now your job is to find out individual values of delta L AB and delta L of BC. ठीक? So this is half of the job done. Second part is, if you look at AB, this is supported from one end. If it is supported, obviously it will provide a reaction. If it is supported from one end, it will provide a reaction. So let us quantify those reactions. So if you want to quantify those reactions, this is the reaction offered by A and this is a reaction offered by C. ठीक है, the direction of the reactions is arbitrary. You can choose anything. If your answer comes out to be negative, that means your chosen direction was wrong. ठीक है, so it is your choice that you can choose any direction, whatever you want. But if the value remains positive, that means you are going ahead with the same correct direction. If the value comes out to be negative, that means your chosen direction was wrong. So applying principle of superposition, what do you say? RA plus 100 is equal to RC. डायरेक्शंस आपने तय कर ली अपनी मर्जी से ही सही, आपने तय कर ली. तो अगर हम प्रिंसिपल ऑफ सुपरपोजिशन इस सिस्टम पे अप्लाई करें, सो दिस इज योर इक्वेशन नंबर 2, दिस इज योर इक्वेशन नंबर 1. So these are two statements. Now let us balance it. So to balance it, what you are doing is, let us isolate AB. We are moving from left to right. So this is RA, this is 100. So what we are doing is, this is your reference, this is your manipulator. So we are adding RA and we are subtracting RA. Okay. So this and this are used to balance the entire AB section. So this is AB. So AB actually becomes like this. This is RA and this is RA. What are you left with? You are left with 100 plus RA in this direction. You're left with 100 plus RA in this direction and RC in the other direction. Now you can see 100 plus RA and RC are the same. So this is automatically balanced. So if it gets automatically balanced, that does not mean that you are doing this problem correctly. It only means that you have balanced the loads properly. So this you can write it as 100 plus RA, and on the other side again you have, instead of writing RC, you write 100 plus RA. Okay. Now let us use equation number 1. Using equation 1, what is delta L of AB? This is compressive. So you have RA into length of AB is 0.4 meters. So this is 400. We are converting it into mm. Okay, divided by AE. Now in A, you see that it is,
Excuse me, sir.
1 minute. First, let me complete. So phi is equal
Okay.
to 30. So phi is equal to 30 means, if phi is the mechanical designation of, phi is the mechanical designation of diameter of dia, and it is written in mm. So it is the, if anywhere in a mechanical drawing you see the statement phi is equal to 30, it means that you want to say the diameter of the shaft is, or the diameter of the component is 30, and if nothing is given, it means it is mm. So this is pi by 4 30 square into E. E is 200 GPa. E is 200 GPa. Now GPa is gigapascal. So this is 200 into 10 to the power 9 Newton per meter square. Now if you convert this into mm square, this is 200 into 10 to the power 3 Newton per mm square. To convert meter to mm, you have to divide it by 10 to the power 3. It is square, so it is divided by 10 to the power 6. So if you divide this by 10 to the power 6, you get 200 into 10 to the power 3 plus delta L of BC 100 plus RA multiplied by the length is 600 mm divided by this is multiplied by 200 into 10 to the power 3 plus pi by 4 into 30 square multiplied by 200 into 10 to the power 3. Now this whole term is preceded with a negative sign because both are compressive. So this is preceded with a negative sign. Now this is equal to 0. From this you can find RA. Once you know RA, RC can be found out. Okay, so once you know RA, RC can be found out. Now what the question was, determine the stress in AB. So the effective load in AB is RA. So stress in AB is given by RA divided by pi by 4 30 square, force upon area. So whatever value you get, it is the stress which is applicable for member AB.